Hi everyone, this is Umasankar, All India IIT Coordinator. Yeah, actually now we are concentrating on vector algebra, and in the first class or lesson number 1 of the vector algebra, we have concentrated on the properties of vectors. Now this is about lesson number 2 on properties of vectors. Yeah, actually in lesson number 1, I have concentrated exclusively on the basic definitions and important notations in vector algebra. Because my friends, actually if you are good at vector algebra, then you can do wonders in complex numbers. Complex numbers and vector algebra, they are interlinked to one another. Of that, properties of vectors play very good role. So in lesson number 1, successfully we have completed properties of vectors, and now through this lesson, here I am presenting the remaining properties of vectors. Of that, what are the directional cosines and vector equation of a line and collinearity of the vectors. Of course, collinearity and coplanarity we have discussed in the lesson number 1. Again here, the best theorem in collinearity of the vectors, here I am going to concentrate. That is why, and direction cosines and direction ratios of the vector, as well as vector equation of the line, if possible vector equation of the plane I may cover. Let us see. What are the directional cosines? Okay. See my friends, directional cosines. Suppose this is my plane, origin, this is x axis, this is y axis, this is z axis, and P is any point, okay, P is any point on the system on OXYZ plane, and this is vector OP bar, position vector of the point P. If it makes an angle alpha with x axis and an angle beta with y axis and angle gamma with the z axis, then cos alpha, cos beta, cos gamma, these are called directional cosines of the vector OP bar. These are called what? Directional cosines of the vector OP bar. In general, the directional cosines are represented with L, M and N. So L is nothing, these are all are the standard notations, don't get any confusion. So L is nothing but cos alpha, M is nothing but cos beta, N is nothing but cos gamma. What is cos alpha, cos beta, cos gamma? Alpha is the angle made by the position vector OP bar with x axis, and beta is with y axis, and gamma is with z axis. Okay, and they are represented with what? L, M and N. And properties based on these three that we are learning in 3-dimensional geometry. Actually, here just I am concentrating the basic definition of the direction cosines. Okay, my friends, see that definition. Suppose a bar equal to, say for example, a bar equal to a1i plus a2j plus a3k. This is any vector, and the angle which the vector makes with the positive directions OX, OY, OZ are called the direction angles. Another name is nothing but their cosines are called direction cosines. See the name itself, direction cosines. Direction plus cos angles, that is why direction cosines. Or we can also simply call it as the DCs of the vectors. Okay, and here cos alpha is a1 by a bar, cos beta is equal to a2 by mod a bar, cos gamma is equal to a3 by mod a bar. What is mod a bar? Magnitude of the vector a bar. So this is what coefficient of I or component, and this is j component, this is k component. You divide a1 with magnitude of the vector, which gives what? Cos alpha. That means the angle made by the vector in positive direction with x axis, and cos beta is nothing but a2 by a bar, and cos gamma is nothing but a3 by a bar. This is the basic definition of what direction cosines. Already I told, In general, they are represented with what? L, M and N. So, I can also write it as L is equal to, and this I can also write as L, this I can also write it as M, this I can also write it as N. And in detailed concepts of direction cosines and direction ratios, we will in three-dimensional geometry we will do it, or I may give more exposure on this particular area. And moreover, cos square alpha plus cos square beta plus cos square gamma, sum of the squares of the DCs of the vector. What does it mean? Sum of the squares of the direction cosines of any vector is always equal to what? 1. How come? What is cos square alpha? That is nothing but a1 square by mod a bar square plus a2 square by mod a bar square plus a3 square by mod a bar square. This is about cos square alpha plus cos square beta plus cos square gamma. So, LCM is same, nothing but what? Mod a bar square. So, in numerator it is what? a1 square plus a2 square plus a3 square. That is nothing but what? Mod a bar square by, this is also equal to mod a bar square, both gets cancelled, you will get that as 1. So, for any vector, sum of the squares of the direction cosines is always equal to 1. You have to practice this result. And next, vector equation of a line and that we are finding, and first read the statement properly. Parametric vector equation of a line passing through the 2 points capital A bar and capital B bar is given by. So, R bar is equal to A bar plus T into B bar minus A bar. This is called parametric equation of the line, and here this is the equation of the line passing through the points A bar and B bar. And my friends, actually we have practiced the same type of formula in coordinate geometry also. Actually, in coordinate geometry, if A x1 y1 and B x2 y2 or 2 points are given for you, then what is the equation of the line passing through AB? Immediately you can write it as y minus y1 by y1 minus y2 equal to x minus x1 by x1 minus x2. This is what? Equation of the line passing through 2 points. This is equation, and this equation contains the terms in x and y. Whenever any equation which contains the terms in x and y, that equation is called Cartesian form of the line. And after simplification, you may get the standard form. Of course, the equation of the line in standard form in a 2-dimensional geometry is like this, and whereas in a 3-dimensional geometry I am adding any the extra term ax plus by plus cz plus d equal to 0. This is equation of the plane, I can say. Okay, this is equation of the line since it is passing through 2 points. See there, actually in the beginning of the vector algebra also I suggested and I stressed more on this point. My friends, everything is same. All the topics are almost all same. Just before entering into that particular topic, one should learn the basic definition and the important terminology. If you have been understand the basic terminology and the notations properly, then solving the problems with help of that particular terminology and notations only the matter. Okay, that is the way to learn any particular topic. So, my friends, actually this is about what? Cartesian form. Now, coming to in vector algebra, just like in vector algebra, just like in Cartesian form, in vector algebra, if I am representing any equation, line equation like this, r bar equal to a bar plus a t into b bar minus a bar, this is called parametric. This is what I can say, parametric vector equation. Here t being the parameter, that's why. Parameter means any real number, any number I can imagine, any number. You put instead of t that has 1 or 2, minus 1, half, 3 by 4, 5 by 6, you may get infinitely many number of lines. because between 2 points, this is the line, equation of the line. Based upon the equation, you may get the equation of the line. So, how to get it? How to get it? That is important. Say these are what are A and B? These are the 2 points, and say for example, this is capital A bar, and this is capital B bar. These are the 2 points. So, whenever 2 points are given for you, I am taking O as my fixed point origin, then OA bar becomes what? Position vector of the point A, and OB bar becomes position vector of the point B. So, this is nothing but A bar, and this is nothing but B bar. Okay, my friends? This is what vector AB bar. This is nothing but vector AB bar. Say for example, here capital P R bar or capital R bar, whatever it may be, is any point on the line. Then the position vector of R bar here I am going to find. So, if you have observed the diagram properly, it is very clear that the vector RA bar, the vector not RA bar, or conveniently what I am writing is here, the vector AR bar, the vector capital AR bar is parallel to the vector AB bar. So, in first lesson what I told, whenever 2 vectors are parallel, I can represent one as a scalar multiple of another. So, AR bar is equal to some scalar T into what is that? AB bar. See, whenever vectors considering vectors with the same initial point, then the vectors are called co-initial vectors. This is another definition in vector algebra. So, when do we say co-initial vectors? If the vectors having the same initial point, simply the vectors are called what? Co-initial vectors. So, if 2 vectors here in the diagram, since they are on directed one line segment, and as per the definition of collinearity, here these 2 vectors are parallel, and whenever these 2 vectors are parallel or collinear, simply one is nothing but a scalar multiple of another. So, here AR bar is, that is OR bar minus OA bar equal to T into what is AB bar? OB bar minus OA bar. So, this is R bar minus A bar equal to T into this is B bar minus A bar. So, R bar is equal to A bar plus T into B bar minus A bar. This is what equation of the line passing through 2 points A bar and B bar. Why I am giving the proof of this particular concept? Because once you have understood the knowledge behind the screen, that steps and that information may help you for solving other problems in coming lessons. Okay? In that aspect, you need to practice these formulae. And similarly, my friends, the second one is the equation of the line passing through the point capital A bar and parallel to the vector B bar. See, try to understand the difference between these two. One is what? Equation of the line passing through 2 points, whereas in the second one, equation of the line passing through the point, this one, here equation of the line passing through the point, this one, and parallel to this one. That means, say this is my point A bar. Whenever that kind of points are given, immediately I have taken position vector. So, this line I am going to find, and this is the vector parallel to another vector, say this is vector B bar. So, what can I say? This is the line I want ultimately. What is the beauty of this particular line? It passing through the point capital A bar and it is parallel to the vector B bar. So, this is the situation. So, if I have taken any point R on this particular line, so position vector of R is nothing but OR bar, that is R bar. So, from the diagram it is very clear that the vector AR bar is parallel to vector B bar. So, AR bar is equal to some scalar T into B bar. So, what is AR bar? OR bar minus OA bar, which is equal to T into B bar. So, what is this? That is R bar minus A bar equal to TB bar. So, R bar is equal to A bar plus TB bar. This is what? Vector equation in parametric form. Why it is called parametric form? Because of this parameter t. So, this is what equation, vector equation of the line passing through the point and parallel to, this is what equation of the vector passing through 2 points. Okay, my friends. Actually, here I am the same thing I am representing with the diagrams also. Please practice these two techniques. Here the formulae are very important. And again, the same things, if you have converted everything in Cartesian form, then automatically that is nothing but what vector equation of the line passing through 2 points and equation of the line passing through a point and a parallel to the vector, that you will learn in 3-dimensional geometry, lines and planes session also. This is the modest beginning for that one. Okay. So, see my friends, these are the things. So, these from the figure it is very clear for you. Here obviously this vector I have completed this one. Here this vector parallel to this vector AB bar, and here this vector is parallel to these two are parallel, and moreover here these two are parallel. Apply this one, you will get it. And another important point is, this is again very useful for solving some of the difficult questions. In general, in your board examination, nobody will ask the questions on this particular area, which is nothing but angular bisectors of two vectors. The same angular bisectors we will learn in straight lines also. Even in 3-dimensional geometry also we will practice. The same things, why I am stressing more? Because the same things again and again you are practicing in coming chapters also. That is the link between one area to another area. So, here my friends, equation of the bisector of the angle between, that means angular bisector. If two lines are given for you, suppose these are the two lines, then this is the angle between two lines, and this is called angular bisector of these two lines. This is line L1 and this is line L2, and if this line makes equal angle between these two lines, then this line is called what? This line is called what? Angular bisectors of line L1 and L2. And if this line is the internal angular bisector, then this another angular bisector which passes through like this is called the external angular bisector. So, for every two intersecting lines, there exist two types of angular bisectors. One is internal angular bisector and remaining one is external angular bisector. So, if two lines are given for you, say r bar is equal to a bar plus lambda b bar, r bar equal to a bar plus mu c bar, then the angular bisectors are r bar equal to a bar plus t into b cap plus c cap, or c cap plus b cap, r bar is equal to a bar plus p into c cap minus b cap. What are b cap, c cap and c cap, b cap? They are what? Unit vectors parallel to b cap, b bar and c bar. Okay. So, one is internal angular bisector, then obviously the remaining one is external angular bisector. Of that, what is the internal angular bisector, what is the external angular bisector is the important issue that we will learn in solving the problems. I will explain those concepts, those fundamentals very clearly for you, do not worry. Okay. So, whenever two intersecting lines are given for you, just like in coordinate geometry, even in vector algebra also, with the help of these two particular formulae, we can calculate the angular bisectors. So, for any two intersecting lines, how many angular bisectors will exist? Two angular bisectors. Of that, one is what? Internal angular bisector. Obviously, the remaining one is what? External angular bisector. Okay, my friends. So, if it is an internal angular bisector, obviously it is what? External angular bisector. That is the difference. Okay, my friends. Now, coming to collinearity. This is called fundamental theorem of collinearity. This I can also say it as fundamental theorem of collinearity. Here my definition is very important. Based on this particular definition only, in advanced examination, several times the problems were repeated. So, what is that? If three position vectors, three points A, B, C with the position vectors A bar, B bar, C bar. So, my friends, listen very carefully. 3 points are given for you. So, whenever 3 points are given for you, and we can say that the 3 points are collinear. When can we say the 3 points are collinear? If and only if there exist scalars x, y, z, not all 0, such that xa bar plus yb bar plus zc bar equal to 0, where x plus y plus z is equal to 0. This xa bar plus yb bar plus zc bar equal to 0 bar is nothing but, my friends, it is not 0 bar, because this is scalar multiplication of a vector. Scalar multiplication of a vector is always a vector. Addition of two vectors is always a vector. So, LHS is a vector. So, equate a vector to vector only. So, in general on paper, what we are doing is, instead of writing 0 bar, we are simply represented with 0, which is wrong. So, please be careful with this. So, whenever 3 points are given for you, and if you want to test whether the points are collinear or not, then immediately, if you are in a position to identify 3 scalars x, y, z, not all 0. This is important, not all 0. That means at least one of them is non-zero, such that xa bar plus yb bar plus zc bar is equal to 0 bar, where x plus y plus z is equal to 0. That means what? Linear combination of a bar, b bar, c bar is 0 and sum of the scalars is 0. Then only we can say that the points are what? Collinear. My friends, this is this is called what? Fundamental theorem of collinearity of the points. The same thing we will explain in coplanarity also. That is also called fundamental theorem. This is the modest beginning of fundamental theorem. Even in your higher classes also, in higher classes, suppose if you are in first year BTech, you may study linear algebra. There in linear algebra, of course, at present we are just concentrating on 2-dimensional and 3-dimensional. Whereas in BTech classes, in mathematics, they may introduce or we may enter into n-dimensional space. In n-dimensional place, all these complex numbers and vector algebra, we can completely mix it and utilize them as linear algebra. There in linear algebra, again you study this particular theorem. This is called fundamental theorem of collinearity of the points. So, whenever 3 points are given for you and we want to test whether the points are collinear or not, this is the litmus test. What to do? You have to write any linear combination of these 3 points like this, and if you are proving that x plus y plus z is equal to 0, then simply we can say that the 3 points are what? Collinear. This is called what? Fundamental theorem. Fundamental theorem of collinearity. Collinearity. Fundamental theorem of collinearity. Okay, my friends. Now, hope you enjoyed this video. If you like this, please share and subscribe my channel, and please don't forget to press the bell icon, and moreover, please don't forget to check the description. There I am providing very good assignments and important question papers are also for you, for your benefit. Okay, my friends, we will meet with the next lesson soon. Thank you.